Hey there, and welcome to exercise number 50. In this one, we need to write a function named mergeSortedArrays that receives two parameters. The first one is an array of numbers sorted ascending, we're going to call numbers 1, and secondly, we're going to get another array of numbers, but this time sorted descending, and this one is going to be named numbers 2. The function should return a new array with all the elements from both arrays sorted in ascending order. And here I added a little disclaimer, bonus points if you can do it in linear time complexity. Now below I have an example. So if our first array is 1, 2, 3, 4, and our second array is 8, 7, 6, 5, then the output should be this one, 1, 2, 3, 4, 5, 6, 7, 8. Now if you want to solve this exercise for yourself, which I highly encourage you to do, click on the link in the description. If not, keep watching. Usually this is the part of the video where I say, let's go into the code area. But before I do that, I want to explain my thought process for the solution. I think that's very, very important. So I prepared here an Excalibur, and we're going to use it just to describe the solution. Now, this is the first array, this is the second one. The first one is sorted ascending, this one is sorted descending. Now, we need to create a new array, right? So let me just copy paste this one, and it's going to have the numbers in order. Now, the question is, how do we do that in linear time complexity? Because, as you can think about it, we can just create a new array, put all the items there, and then sort it. But that's not going to be linear complexity. Well, to do this, we can realize that, hey, this one is the smaller number here. So the number in the first position is the smallest. And the number smallest here is this one. So the question which number should be on the first position here is actually a question of, okay, which is smaller? This one, the first one here, or the last one here? And this case is the last one. So I'm going to put it here. Now that we use this number, I'm going to move this one here. Now this is the smallest number, right? So now is the question between 1 and 1. So I can pick whichever. Now let's say I pick the one from the left. So I move this one here. Now, again, the smallest number from the left side is 2. The smallest number from the right side is 1. So we're going to put 1 again. And we move this one to the left, right? Because again, we use those two. Now we get to this number, which is the smallest one we still have in this array. Now, which one is smaller? 2 or 3? Well, it's 2. So we're going to put 2 and we're going to move this one again. Then we're going to, you can guess, we're going to get 3 and 3. So we're going to have, this one's going to move, this one's going to move. And finally, the last two is going to be 4 and 9. And this way, we get linear time complexity because we iterate through this number, through this array once, and through this array once. As you can probably tell if you're used to pointers from other languages, these arrows kind of replicate a pointer, right? So you move them, right, 0, 1, 3, 9, and again, this one is moving through the array. So this is the overall thought process that I have. I want to have like two arrows pointing to the smallest number, and then I'm going to move them around and always pick the smallest number at that point. So this being said, let's now jump into the code area and let's create first the new array. So I'm going to say result is a new array. Now the pointer, the first arrow, let's call it I, this is going to be the index, is going to be 0, right? So for numbers 1, the smallest number is 0. For numbers 2, let's call it j, this one is going to be numbers2.length minus 1. Okay, so this is the position of the smallest number in numbers 2 because we know it's sorted descending. Now I'm going to need to here to create a while. It's going to see, and it's going to be like this. As long as I have numbers in numbers 1 or numbers 2, so as long as I is less than numbers1.length and j is bigger than or equal to 0, so as long as this condition happens, we still have numbers in the array we need to add to result 1. So let's create now two more variables. I'm going to say smallest in 1, in numbers 1, is numbers 1 of I. Smallest in numbers 2 is numbers 2 of j. Now, we need to compare those. So if smallest in number 1 is less than smallest in number 2, what do I want to do? Result.push. We're going to put this one in the result, and I want to increase I. So this means actually moving the arrow to the right. Otherwise, I'm going to put, it's going to be the reverse. So I'm going to say smallest in number 2, and j is going to be smaller, right? We move the arrow towards the left because the numbers 2 array is sorted descending. Now, at some point, we might arrive with a number here, like we already used all numbers in numbers 1, but we still have numbers in numbers 2, or the other way around. So we also need to take into we need to take into account this scenario. So I'm going to say if we reach the end, so I say if I is bigger or equal than numbers 1 dot length, used all numbers in numbers 1, let's just put all numbers in numbers 2. So actually, I don't need the second commentary. So we used all the numbers here. So now it's obvious I'm going to push numbers 2 of j, and I'm going to do this, right? Because it's obvious, like we have no more numbers in numbers 1, so there's no point comparing. At the same time, if j is smaller than 0, then used all numbers in numbers 2. So here I'm going to need to add a number from numbers 1, and I'm going to need to increment I. Now, if neither of those is true, here we're going to need to do a continue because, if neither of those is true, we get here. We get smallest in numbers 1, smallest in numbers 2. We push whichever one it is, and then we're going to keep going with the while loop. After we iterate through all the numbers, we get to the end. So let's go here, and I'm going to say return result. Now let's test our code. So I'm going to say console log merge sorted arrays of, and let's take here numbers 1, and let's take this one, and we get just numbers 1, and that's because, oh yeah, here we need an or. So as long as we still have numbers, right? Because if we have an and, as soon as we finish with an array, it's done. So you can see we get 1, 2, 3, 4, 5, 6, 7, 8. Now this looks good. So let's test our code, and voila, it works. Cheers, and see you in the next one.